Hi, we've now come to the fourth lecture, which is still on surface vector analysis, surface streamline analysis for West and North Africa. We've just been through with that of lecture 3, involving surface vector analysis for North Africa and Europe. Now this is the map, cropped map for North and West Africa. Looking at this cropped map, we look at the stations and the winds. The winds at the station. This one, the wind is coming directly from the south and going towards the north. That's here. Looking at my cursor, we have to analyze the streamline. As I said earlier, streamlines are lines drawn tangential or parallel to the instantaneous wind velocity. So this is the direction from south towards north, and the wind magnitude is, there are about 3 branches and a small, that is 35. 10, 20, 30, 35, but we're not concentrating, as I said earlier, on the wind magnitude, but on the wind direction. The same thing here for this station. The direction is almost south, going towards north. Then this one is around southeast, and going towards north of northwest, west. And this is the station. Then this one here again, the wind is almost like it's a westerly wind, that is, it's moving from this side to this side, while from here is from the south and then turns around. So in the analysis, we draw lines that are parallel. So starting from here, the winds here tell us here, of course, let me start from here. The wind here is from around the southeast and going towards northwest. So we take the line parallel. Then as we are coming close to this station here, the wind is around from southwest and going towards northeast. So we have to bend it in respect of this to be parallel. And again, as we go northwards, we see winds that are not going from south to north. It's around south of southeast to north of northwest. So we take it that way. This second one here, we also take it parallel and continue the same way. And then it joins here. Okay, this is another asymptote of a convergence. Then this one again, we take it like that, parallel. And then it stops there. Then this one already, as I said earlier, this is already analyzed map, but that's an easier way to give us guide on how this is analyzed. So this is now another line taken that way. And we're looking at here, we see all these areas are without data, very scanty data. So we concentrate on only where we have the data. And this, again, we take it from south. But as we get here, we see that we continue northwards, and then bend towards northwest because of the wind there. And there's a wind here that is telling us something around westerly, or west of it's almost westerly, but slightly north of westerly. And then this wind will now branch in respect of this and turn towards this direction. And this branching here is this is what is called asymptote of divergence. And then we come over to this side. Coming over to this side, you see the station, the wind again is around southwesterly. So we take this line parallel, but as we are coming towards the coast, there's a wind here that suggests that it's a westerly. So we take it towards the west, I mean to the east like that. That's the wind coming from west to the east, is a westerly wind. Here again, we take another one. Of course, we put all the arrows. All streamlines must be indicated with arrows, showing the direction of the flow of the wind. Then this, we take it this way. And as we come here, we have to respect this direction and branch. And of course, another wind up north here is telling us we have to go northwards. So the wind is again branching, showing an asymptote of divergence. It continues like that. Then over here, it turns around, because the wind here also is showing that direction. It turns and then goes round here in an anti-clockwise fashion. Since it's an anti-clockwise flow, this is a C, which is a cyclone. And this area is again what we call the neutral point, because here the wind is diverging here, asymptote divergence. Over here, this side is also diverging this way. So which in which the wind is coming in like that, and that like from here also, and then going out this way and that way. So at this point, the wind is almost zero. It's zero, neutral point. So this is a neutral point. Then the wind diverges like that, asymptote of divergence, and then joins here. Well, we have another anti-clockwise flow. Anti-clockwise flow, and that is a cyclone. All right, so it continues like that and that way. Then here again, we have another neutral point coming this way. And here we take this. This one is down like that, and then joins over here. It's southwards to this point, where it becomes an anti-clockwise flow. Now another one we take parallel to this and down there. Then we have wind here. We have to also draw a line in respect of that, parallel to this wind, and then the arrow shown. And over here there's a one wind that is curving. We have to take it that way. So that is how this has been analyzed. Of course, here this is another line taken this way and there. So this one is relatively few because there are no data here. And that is how this has been analyzed. That is for West Africa, and then West and North Africa. And all these cyclones are also even shown in the scale analysis. So at this juncture, now we want to again stop. So the next lecture, which is the lecture 5, we will be dealing with again scalar analysis. This time around, we'll be looking at contours, geopotential height contours, and that is at upper level now. We'll be leaving the surface and going to upper level, but this upper level is 925 hectopascal level. Okay, so at upper level, we take constant pressure and analyze the geopotential height, the height of this constant pressure from the sea level. So we'll be dealing with geopotential height contour at 925 of the same map of 27th of February 2013 at 12 GMT, but not at surface this time, but at 925. Well, thank you very much. We hope to see you another time. God bless.